Hello, this is just a quick overview of what we did in class today, Friday. So we're talking about angles in standard position. So the first thing about an angle in standard position is that you need to get its vertex at the origin. And then the initial side always goes out along the positive x-axis. So we always start on the positive x-axis. If we have a positive angle, we spin in a counterclockwise. That looks like a times. It's supposed to be a plus. It's a positive angle. I guess I could erase that. A positive angle, we're spinning in the counterclockwise direction, and so that is a positive angle. Looks like, maybe about 90 plus 45, about 135 degrees, or 3 pi over 4 radians. If we have a negative angle, we still start on the positive x-axis, and now we spin clockwise. And so if we have a negative angle of about the same amount, negative 135 degrees or so, we'd be in the middle of the third quadrant. So standard position, always start on the positive x-axis, spin counterclockwise for a positive angle, clockwise for a negative angle. Once you have that set up, you can now have what are called coterminal angles. And so coterminal angles are angles that stop in the same spot. Coterminal. They have the same terminal side. And so in this case, I'm going to draw a couple angles here. So I'm going to draw an angle with positive pi over 6 radians. Right? So I went counterclockwise. Pi over 6 radians, remember, is 180 degrees divided by 6, which is 30 degrees. And so that looks like a reasonably close to 30 degrees. And so now I can go back the other way, and I can end up in the same spot. If I'm going back the other way, that's a negative angle. If I had gone all the way around, a full revolution in radians is 2 pi. And so that would be 12 pi over 6, and so I didn't quite make it all the way around, and so I would have negative 11 pi over 6. And so negative 11 pi over 6 and pi over 6 are exactly the same angle. They're coterminal. They stop in the same spot, which is right here in the first quadrant, up 30 degrees. And you can do this lots of different ways if you're willing to go around the circle more than once. And so if I again get the same starting angle, so I have pi over 6 radians. Another way I could get there is I could go all the way around the circle once, that's 2 pi radians, and then just go that little pi over 6 more, and so I have 2 pi plus pi over 6. That's 12 pi over 6 again, plus pi over 6. That's 13 pi over 6 radians. And so if I was willing to do it again, I could add another 12 pi over 6, and I'd be at 25 pi over 6. I could go around the whole thing backwards a couple times. And basically, there are infinitely many angles that are all coterminal with pi over 6. And the way you get there is by adding or subtracting a full revolution. And a full revolution in radians is 2 pi. And so the way I write this is I write pi over 6 plus 2 pi k, and then I just make a little note here that k can be any integer. K can be any integer. And so k could be 0. If k was 0, I would just get my pi over 6 back. If k was 1, then I get pi over 6 plus 12 pi over 6, 2 pi, which is 13 pi over 6. If k was 2, I would have pi over 6 plus 4 pi, which is another 12 pi over 6, 25 pi over 6. K could also be negative. It could be negative 1. Pi over 6 minus 2 pi would be the negative 11 pi over 6 that I had before. If I made k negative 2, that'd be pi over 6 plus negative 2 pi, or minus 2 pi, minus 4 pi, which would be negative 23 pi over 6. And so this list can go on forever in both the positive and negative direction. There are infinitely many angles that all stop here. Of course, pi over 6 is the most user-friendly one, but all those angles are coterminal with it. They all stop in exactly the same place.